Hello students. So in the last class we had discussed about the banking of road, okay, and basically the designing of the road, and we haven't seen any examples on those concepts that we had learned in the last lecture. So today guys, I'm just going to take few examples on the concepts that we have discussed in the last lectures. Okay, so let's take a problem, and then we will see some more problems after that. Okay, so guys, the question is like this, that a car goes on a horizontal circular road. Okay, so just I'll be making the figure along with the question. So guys, it is, let's say, there is a this is a horizontal circular road, guys. Okay, so it is saying a car goes on a horizontal circular road of radius r is equal to root 27. Okay, so guys, the radius of this is given root 27 meter. Okay, and the speed increasing at a constant rate. Okay guys, so this is your car, let's say. So its speed means, guys, what? A tangential. I hope you're getting my point. Its speed is changing with a constant rate. Okay, and that is given how much? 1 meter per second square, guys. That is given how much? 1 meter per second square. That is what, guys? D mod v by dt. Okay, this is given to you. After that, guys, it is saying starting from the rest, it means u is equal to what, guys? 0. The friction coefficient between the road and the tire is 0.2. Means, guys, here the friction coefficient is given mu is equal to what? 0.2. So guys, mu s and mu k, both we will take what? 0.2 only. uh, After that, guys, they are asking find the time at which the car will skid. Okay, so find the time at which the car will skid. So guys, it's a simple problem. If you see, we know that the car will skid, the car will skid when the force needed to sustain the motion will become more than the force available to make it possible. So guys, this is the very simple thing that is needed here to understand. So guys, we know that because here friction is only the force which can help you to sustain this motion. Okay, and guys, here friction is participating in two things. Okay, one is what? It is helping you to give a tangential that you are having. Okay, a tangential that you are having is because of what? Friction only. And along with that, guys, because you are moving on a circular path, you need some centripetal force also. So that centripetal force, okay, this centripetal force is also coming from what, guys? From the friction. And this a tangential is also, guys, which is coming because of what? Some tangential force component. Okay, so guys, the friction would be acting in this direction, and if this friction that is needed is, guys, is not enough to provide from here, then guys, it will get what? Failed, and the skidding will happen. Okay, so I hope you understood the logic. So guys, let me do the solution for it. Okay, so solution. So guys, if you see, it's a very simple question. So guys, if you see, the friction available that we have, we are of course talking about the limiting situation. So friction available will be what, guys? Mu into m into g, because body is in vertical equilibrium. Okay, no, it is lying on a horizontal road. So guys, the friction will be what? Mu mg. So let me calculate the value. If you want, I can calculate that, or let it be. Okay, we'll put the values in the last. Now guys, if you see, at any moment when the skidding will be going to happen, okay, at any moment when the skidding is going to happen, let's say your velocity is v at this moment. Okay, your velocity is what? V at this moment. So guys, you need some centripetal force towards this, and that will be what? M v square r. And of course, guys, you are having continuously a like a acceleration that you are having in the tangential direction, that is what A tangential, and that is what guys 1 meter per second square. So guys you need a force here MAT in this direction, okay, MAT in this direction, because your force is what sorry, acceleration is what, constant. So guys this is the net force that would be needed in this direction, okay. Just a minute guys, so let me put some other color here. So guys we need some net force in this direction because of this A tangential MAT and this MV square R. I hope you're getting my point, okay. So guys what we can say, we can say that the net force required, okay, so F required at this moment is guys what, is equal to under root of MAT whole square plus MV square R whole square, okay. I hope you're getting my point. Now guys this should be at the limiting condition when the just skidding is going to happen guys. It should be equal to what, F required should be equal to what, F available, okay, F available, and that is what, that is nothing but mu mg, okay. I hope you're getting my point. I'm going a little bit what more in a elaborative way, so I'm taking many steps here, but I just want to explain you the stuff that what is happening here. I can do this thing in a 2 line also, but guys just to give you a proper explanation that how the things are happening, please I'm going in a much detailed way, okay. So guys the F required is MAT square plus MP square by R. Now guys what is this V? V is nothing but what, the magnitude of the velocity, okay. And guys this V we can directly calculate. V is equal to U plus AT, okay. I hope you're getting my point. So guys U is what, 0 in the start, okay, because I have told you when we are doing the circular motion, so along the circular path guys we can use the formula V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS, considering that here S is not the displacement, it is actually the distance, okay. So that idea only guys I'm using here. So guys what we can say, this will be of course A tangential. So guys V is equal to what, A tangential into T. So guys if I put these values here, what I'll get, if you see, so mu is 1 minute, okay, mu mg is equal to under root of guys m square at square plus m square. V is equal to what guys, at into t ka whole square, so at into t power 4 divided by r square, okay. So guys this is the thing, okay. So guys I can take m common, at common if you want, okay guys, and if let me put the values, so mu into g, guys cancel both the sides, okay. If I can take m out, okay, so guys what we are having in the answer here, we are having 80 square plus 80 power 4 t power 4 divided by r square guys, okay. Let me put the values now. So guys mu is 0.2, if you see, mu is given how much, mu is given guys 0.2, and r is root 7, and 8 is equal to what guys, 1. So let's put the values guys directly now. So guys mu is 0.2, it will become what guys, it will become 2 now, okay, it will become 2 now. And guys here 80 is how much, 1, so this will become 1, and this will become what guys, t ki power 4, and r square is what guys, root 27, so root 27 square, that is what guys, 27 only, okay. So 27 guys, do the squaring both the sides, so it will become 4 is equal to 1 plus t to power 4 divided by 27, and this will become what guys, 3, okay, 3 into 27, okay. So guys if I do the calculation, it will become 3 is equal to t to power 4 divided by 27, and so t to power 4 is equal to what guys, 27 into 3, that is 81. So guys t is equal to 3 seconds, okay, t equal to what guys, 3 seconds. So what we can say, that after 3 seconds guys, we will going to observe the skidding of the bike or the car on the road. Okay, so guys, it's a very simple problem. I have done the solution in a much more detailed way as much I could do, and I hope you understood this first example, that how the things are happening. Okay. Okay, now uh, guys, let's take one more problem on this concepts. Okay, these concepts that we have discussed. Okay, so guys, let me write down one more problem for you. So question number 2. Okay, let me change the color first. So guys, the question says like this, that a cyclist is moving on a circular track of radius 80 meter with a velocity of 72 kilometer per hour, guys. Okay, so guys, this is a, you can say, a road. Okay, and on this there is a cyclist which is coming, guys. Okay, and this radius of circle is given how much, guys? 80 meter. Okay, 80 meter, and cyclist is coming, guys. Okay, and it is having a velocity of 72 kilometer per hour. He has to lean from the vertical approximately through an angle tan inverse 1 by x. Okay, so guys, they are asking that, let's say, the theta from the vertical, that it is bending itself. So guys, let's say this is the cycle. Okay, and it is bending like this. Okay, and guys, I'm just trying to make the figure just to understand you. Okay guys, so this is the person, and guys, he is bending his cycle from here, let's say theta. So this theta is given in terms of, like, guys, this is an integer based problem, so it is theta is equal to tan inverse 1 by x. Now uh, yes, he has to lean from the vertical approximately through a angle tan inverse 1 by x. Find the value of x. Okay, find the value of x. So guys, here, because there is no friction has been given in the information, it means, guys, what we should ignore the effect of what friction right now. We should just think in terms of that normal force is only going to help you to take this turn. So guys, if you see here, the normal force that you are going to have, see, mg is going to be like this. Okay, vertically downward, but guys, normal force is going to be what, like this. I hope you're getting my point. This is the, guys, direction of what normal force that you are going to have in this direction. Now if you see, guys, if this is theta, so this will be what, if this is, guys, n, this will be what, n cos theta, and this will be what, guys, n sin theta. Okay, so guys, what we can say, we can say that because the body is in the vertical equilibrium, it means mg should be equal to what, guys, n cos theta. That is the first equation. And because, guys, it is taking the turn with the certain speed, so guys, it should need a centripetal force towards the center to do that thing. So guys, how much centripetal force it needed? It needed mv square by r, and that should be equal to what, guys? Who is going to give it, provide this thing to you, guys? It is going to provide it by what? N sin theta only. Okay, so guys, here I can write mv square by r is equal to n sin theta. So guys, if we divide the 2 by the equation 1, so what we will get, we will get tan theta is equal to, v square divided by rg. Okay, tan theta is equal to, guys, what? V square divided by rg. So guys, theta is going to be equal to tan inverse v square divided by rg. Okay, I hope you're getting my point. So guys, let me put the values now. So theta is equal to tan inverse, v is given how much, guys? It is given 72 kilometer per hour, I guess so. Okay, so guys, speed was given 72 kilometer per hour, which is, guys, nothing but, if I convert in the meter per second, it is 20 meter per second. I hope you know the conversion, guys. You can multiply this with the 5 by 18, you can convert it into meter per second, guys. So let me put that here, guys. So this is 20 into 20 divided by r is what, guys? 80, and g is what, guys? 10. So if I solve this, guys, this is 4, and this is 2, and this is what, guys? 2. So it will become tan inverse 1 by 2. So guys, x value is what? 2. That would be what, guys? Our answer that we were looking at. Okay, so I think, guys, you have understood this question also. It is also a very simple problem, not like difficult as such. Okay, now let's see, guys, one more problem here. Okay. Okay, guys. Okay, let me write down guys question number 3. Okay, question number 3. So question number 3, guys. Let me pick it for you. Okay, something that I can like show you some sort of learning from there. So mm, yes, I think this question can be helpful, guys. Okay, so a motorcyclist wants to drive on a on the vertical surface of a wooden well, okay, of radius 5 meter in the horizontal plane with a speed of 5 root 5 meter per second. Find the minimum value of coefficient of friction between the tires and the wall of the wall, okay, so that he can do that thing. Okay guys, so let's discuss this question. It's a simple problem. It's not more of a like banking problem or a road designing problem, but yes, we can take it. Okay, so let me take this problem for you. Okay, I think it will also give a certain understanding that how the things are happening actually. So guys, let's say this is the picture. Okay, so guys, what it is saying, it is saying a motorcyclist wants to drive on a vertical surface of a wooden well of radius 5 meter. Guys, this is given how much? 5 meter. Okay, and guys, in a horizontal plane it is going to move in a what guys, this horizontal plane you can say. Okay, and what it is saying, it is saying that the speed that it is having with whom it wants to guys move. Okay, just a minute guys, with whom it wants to move, this speed guys is given. Okay, this speed that is given is 5 root 5 meter per second. Okay, 5 root 5 meter per second. And now it is saying that to make it so, what should be the minimum coefficient of friction we need between the tire and the wall. Okay guys, so this is a very simple problem. So guys, if you see here, there is a weight that is going to act in the downward direction. Okay, and there is normal force in this direction, and of course the body has a tendency to go down guys, so friction will act up. Okay, I hope you're getting my point. So guys, let me just show the direction of what things, the friction force and everything. So guys, downward side you will have mg, this side guys you will have some normal force. Okay, you will have some normal force, and this side guys you will have what, some friction force. Okay, so guys, see, if you want to rotate in this circular path, horizontal circular path, you need some centripetal force towards the center, which can fulfill your centripetal condition. Okay, so guys, if you see here, the centripetal condition says that mv square by r should be equal to what, the normal force here. Okay, otherwise the body will not be able to do this circle. Okay, so guys, it means from here I can find out the minimum normal force that we need to perform this thing. Okay, so normal guys, normal force we can find out from here. So guys, normal force will be equal to simply, we can say, m into 25 into 5, 5 root 5 square is what guys, 25 into 5 divided by radius is what guys, 5. So 5 5 cancel guys, normal force is equal to 25 m. I hope this is settled. Okay, now guys, the body is performing the horizontal circular motion, but it should be vertically, it should be in equilibrium. Okay, so vertically it is not moving, so guys, net force in the vertical direction should be what, 0. So guys, friction force here will be balancing whom, mg, and friction force will be guys what, mu into normal force. Okay, and that is equal to what guys, mg. So from here, if we are talking about the limiting condition, the mu into n is what guys, 25 m is equal to m into g is equal to what guys, 10. Okay, we can take g is equal to 10 guys, so mu is equal to what guys, 10 divided by 25. So guys, this is how much, this is I think 0.4. Okay, so 0.4 value will be what guys, your friction coefficient in this case. Okay, so this is also a very easy problem. Okay, if you understand the concepts guys, and if you just apply the basic algorithms to solve a certain problem, I think all the questions are like a bit easier only. Okay, something, this is the thing that we have to follow. Okay, now let me take one more problem guys, that I can take something good. Okay, so okay, let's take one more problem. Question number 4 guys. Okay, question number 4. So we'll take this one more problem, and I think that would be sufficient after that to understand that how we should use the concepts of this of banking and everything in the horizontal circular motion. So guys, this is the problem. Let me read this question. A toy car is moving on a circular track of a radius 1 meter guys. Okay, so let me make the circle guys. Okay guys, what is given? The radius of this is 1 meter. Okay, after that what is saying? A toy car is moving on a circular track of radius 1 meter. Speed of the car is given by v is equal to t meter per second guys. So it is moving on this guys, but its velocity is what? Changing with the time. V is what guys? T meter per second, means at t equal to 1 second velocity is 1 meter per second, t equal to 2 second velocity is what? 2 meter per second, something like this. Okay, so guys, the speed is continuously changing. Mass of the car is guys what? Root 2 kg. Okay, so guys, m is given to you, root 2 kg, and after that guys, it is saying that g is equal to 10 meter per second square. Find the friction force acting on the cart at t equal to 1 second. Okay, so find the magnitude of friction force acting on the cart at t equal to 2 second guys. So guys, let's say, because it has been said here that like there is no skidding or nothing is happening. So of course guys, if there is no skidding, nothing is happening, then whatever the force is needed to sustain this motion at that moment would be coming from what guys? Friction force only. So we can just equate those forces, and we can say that this would be the friction force acting at that moment. I hope you're getting my point. So guys, let's say at t equal to, I think at t equal to 1 second they had asked. Okay, let's say guys, at t equal to 1 second the particle is reached here. Okay, the particle is reached here. Guys, it will have the velocity how much? V is equal to 1 meter per second. Okay, so guys, it needs some centripetal force towards the center. Okay, it will need some centripetal force towards the center. So let me make this figure guys. This will be how much? This will be what guys? Mv square by r. And guys, of course, because the velocity is continuously changing in terms of magnitude, so it will be having guys some a tangential. So it means guys, you need some tangential force. So guys, f tangential will be how much? M into at. So guys, of course, you need this much net resultant force, and it will come from where guys? It will come from the friction only. Okay, so guys, just calculate this force, and that would be equal to what? Your resultant force that is needed. So guys, f needed, okay, will be equal to how much guys? Under root of mat whole square plus mv square by r whole square. Okay, so that would be the thing guys. Let me put the values now. So m is equal to what guys? Root 2. Okay, so square of this will be what guys? 2. 80 guys, how do we get 80? So guys, if you see, v is equal to t meter per second. So guys, dv by dt will be your what? The a tangential. So a tangential guys, because here just we are differentiating the magnitude guys, we are not talking about the direction. So guys, dv by dt is equal to what? 80, and that is equal to what guys? 1 meter per second square. So guys, it will be what? 1 only, plus m square guys, that is what? 2. V at that moment is what guys? 1. So this will be 1 divided by r is guys what? 1 only. Okay, so I hope you are getting the answer guys now. So it will be 2 plus 2, that is what? 4. So guys, that answer is what? F is needed how much? 2 Newton. Okay, so guys, this is the simple answer of this problem, that friction needed at that moment is how much guys? 2 Newton. So how much friction will be guys provided? That will be also what? 2 Newton only. Okay, friction provided will be also what guys? 2 Newton only.